This is a problem related to the starters of a DC machine. Why we are using these DC starters? Because during the starting current is very high. Why? Because the starting current or the current taken by the machine is equal to the supply voltage minus the back EMF by resistance in the circuit. So what is there in the circuit? Only armature resistance. It is a very low value, right? So and back EMF is proportional to the speed. So during the starting, the speed equal to 0. This implies back EMF is 0. So when back EMF is equal to 0, the whole difference is high and this is anyway low, right? So as a result, the current drawn by the machine will go high. So in order to limit the starting current, we will be putting an external resistance in the armature circuit. So in that process, the whole scheme is called starter. Okay, now we will come to the problem. So in the given problem, he is told that the armature current shall not exceed twice its full load value. What is the formula for armature current? Armature current equal to supply voltage minus back EMF by armature resistance plus external resistance. This will limit the current, right? So in the problem he has given I equal to 2 times full load current. What is the full load current? He has given 2 into 60. So this is equal to 120 amperes. Just you can substitute in the above. So 120 is equal to supply voltage. How much? Supply voltage is given as 115 minus, what is the value of EB? 0, because during starting EB equal to 0. So what is the armature resistance? Armature resistance is given as 0.12 plus R external. So this implies R external is equal to, if you simplify this expression, you will be getting a value of 0.838 ohms. This is the total external resistance it was connected in the circuit during the starting. Now as the machine picks up the speed, you need to cut the external resistance. So how he is cutting the resistance? As the machine reaches speed, he is cutting the external resistance by 50%, right? So when the machine reaches 400 rpm, how much is the EB value? So we know very famous formula, EB equal to Ka phi omega, or you can say N. So in this is phi Z N by 60 into P by A. Phi is the flux per pole. How much is given? He has given it as a 25 millihenry and the number of conductors are 360 and the speed is given in rpm 400 by 60 into how many number of poles? It is a 2-pole machine and the number of parallel paths are 2. So if you simplify all this value, you will be getting EB equal to 60 volts. Now what is the formula? Same formula, I equal to the supply voltage minus EB by RA plus, this time the value is not external resistance, it was cut by half. So this is equal to by 2. This implies, so how much? I equal to the supply voltage remains constant 115 minus 60 by armature resistance is 0.12 plus external resistance is 0.838 by 2. So you will be land up with the value of 102.04 amperes.